Hello students, welcome to the next concept. This is the topic after electric field. The concept is null point or neutral point. This type of concept we studied in 11th class gravitation also. Null point or neutral point means the point where the resultant electric field electric force is zero. That point is called null point. So here one application I am giving. Two charges q1 q2 separated by distance r. Suppose here is a point in between them. So point P, which is at a distance x from q1, remaining distance is r minus x from q2. So here q2 I am taking as more value, q1 is less. So at this point q1 is giving electric field. So I am considering q1 as positive. Yesterday I told you positive charge gives electric field which is away from it. So electric field E1 given by the charge q1 away from it. Arrow mark dekho. q2 also gives electric field, it is also positive charge, so away from it. So if q1 q2 are giving electric fields E1 E2, suppose if E1 and E2 are equal and opposite, cancel. Substitute. Yesterday I told you electric field due to the point charge. q1 is point charge, distance is x, electric field is E1, 1 by 4 pi epsilon naught q1 by x square. q2 is point charge, distance is r minus x, it is giving electric field E2, 1 by 4 pi epsilon naught q by distance square. So solve this like this and check it. The distance x, I want to find out distance x. So see the calculation carefully, then you will find the distance like this. Distance x is equal to r by root of q2 by q1 plus 1. What is this x, sir? Distance of null point from weak charge. So here what is the weak charge here? q1 is weak charge. I told you q2 is greater, q1 is less. I told you in this slide q1 q2 are positive, that is why here I got plus. Suppose if I will consider q1 q2 are opposite charges, q1 is positive, q2 is negative, like that, opposite charges, then here I will get minus, remember. So that is why the general formula, distance of null point from weaker charge x equal to r by root of q2 by q1 plus r minus 1. So here positive charge you have to take for like charges, negative charge you have to take for unlike charges. So purely it is useful for the numericals. Just remember this thing. Always remember q2 must be greater than q1. And one more important point, keep in mind. So the diagram you can see here, if both are like charges, null point will be inside. If both are unlike charges, this null point may be outside here. So remember this concept. This is only for numericals, check it. Next, coming to the important topic, motion of charged particle in the electric field. Here two topics are there. Charged particle moving parallel to electric field, charged particle moving perpendicular to electric field. First case I am explaining charged particle q moving parallel to electric field. As I told you in the concept of electric field, if any charged particle entering into electric field, on this charged particle force is acting. So the basic formula E is equal to F by Q and force F is equal to, I got this formula from here na, E is equal to F by Q formula is there na, so from this I am writing. So force F is equal to EQ. So force F is nothing but ma, Newton's second law, where m is the mass of this charged particle. So automatically acceleration of charged particle A is equal to EQ by m. So very useful formula, remember. And here if the charged particle q is positive, then the positive charge moves in the direction of electric field. Very important. That means charged particle gets acceleration. If the charged particle, if q is negative, that means charged particle I am sending in the electric field, it will move opposite to electric field, remember. That means it gets deceleration. Very important sentence. Positive charge moves in the direction of electric field, negative charge moves opposite to the electric field. So remember, On the basis of this sentence, I am saying negative charge. Suppose if I am keeping electron here, tell me how the electron will move, in this direction or opposite direction. Electron is negative charge, electric field is in this direction, definitely electron will move opposite direction, keep in mind. So it is very useful. So here I am giving some applications. So basing on the 11th class topic, see the application I am giving here. The application is here a pendulum is having charge q, so mass is m, so downward force is mg, electric field I am applying in downward direction. This electric field gives acceleration, the acceleration is also in the same direction a, so downward acceleration g and acceleration due to electric field is also a, both are in the same direction. Therefore time period of oscillation of simple pendulum t equal 2 pi root of L by G. Here extra a is coming since both are in same direction na? So G plus a, okay, where a is nothing but eq by m. So remember this formula, you will get in multiple choice questions like this. Coming to the next point also, suppose I am reversing the electric field like this, reversing electric field. So see the arrow marks here, electric field is upwards, acceleration also upwards, here acceleration is upwards, here acceleration due to gravity is downwards, arrow marks you can check it. So I am writing G minus a, this is the sentence. Again a is nothing but eq by m. Similarly, if electric field is perpendicular like this, gravity is downwards, electric field is like this, acceleration is a, so g is downwards, a is like this, then resultant acceleration is square root of g square plus a square, and this value I have to substitute in this formula, t equal 2 pi root of L by root of g square plus a square. 2 square root is bigger one is there, inside one another square root is there, check it carefully. So these are the applications which are useful for the multiple choice questions. Take care, and in the next slide I will explain the next concept. So see the slides, I am following the slides just like our classwork notebook yesterday I shared with you. So we will see the next concept in the next class. Thank you.